Hello YouTubers. This video is a basic explanation on the analog values processing. As you know, or maybe don't, CPUs processes analog values in binary form only and only. It means that analog signal needs to be digitized to become readable for the CPU. Analog signals can be either inputs, either outputs. Analog input modules converts analog process signal into digital form, while analog output modules do the opposite, convert the digital value into analog signal. For example, for analog input, analog to digital converter is used. This converter approximates analog value with step curve. Here is our analog value. And here is approximation of that value. Two most important parameters of the approximation are conversion speed and the resolution. In other words, resolution is a precision. It depends on the converter and its circuits. As you can see, an approximation of the analog signal is returned by step curve. The number of increments is directly proportional to the resolution. The shorter the length of the increments applies to higher resolution and adds precision. Let's change the length of the increments. As you can see, we have got less points. It means the resolution is worse. Analog signal can be bipolar, or unipolar. Unipolar signal means that range is positive, between 0 and plus x, while bipolar means that range is between minus x and plus x. Analog values are represented as 16 bits memory area of type integer, where bit 15 is used for sign, and bits from 0 to 14 holds the value. Let's talk about understanding of measuring ranges. Simatic S7 distinguishes between rated range, overrange, overflow, underrange, and underflow. Looking at these two tables, you can see the differences in the ranges for bipolar and unipolar signals. Ranges overflow and underflow are reserved for error detection. Overrange and underrange are for tolerance. As an example, let's take unipolar 0 to 10 volt signal. One bit step will be 10 volts divided by 27,648. Result is approximately 0.361 millivolts. For 15 bits resolution, a step will be 2 power 15 minus 15 equals to 2 power 0 equals to 1. So for 15 bits resolution, approximations is 1 bit. For 12 bits resolution, a step will be 2 power 15 minus 12 equals 2 power 3 equals 8. For 8 bits resolution, a step will be 2 power 15 minus 8 equals 2 power 7 equals 128. According to that, 15 bits resolution step is 1 multiplied by 0.3617 equals 0.3617 millivolts. "12 bits resolution step is 8 multiplied by 0.3617 equals 2.89 millivolts. "8 bits resolution step is 128 multiplied by 0.3617 equals 46.3 millivolts. So, you can see the difference in millivolts, comparing different resolutions. Let's find out the count of steps. 15 bits resolution steps count is 27,648 divided by 1 equals to 27,648 steps. 12 bits resolution steps count is 27,648 divided by 8 equals 3,456 steps. 8 bits resolution steps count is 27,648 divided by 128 equals to 216 steps. Let's check for errors. One step of 15 bits resolution is 0.3617 millivolts. Multiply it by steps count and we should get 10 volts. "10 volts. No errors. One step of 12 bits resolution is 2.89 millivolts. Multiply it by steps count and we should get 10 volts. "10 volts. No errors here as well. One step of 8 bits resolution is 46.3 millivolts. Multiply it by steps count and we should get 10 volts. And again, 10 volts. That was the very basics of the evaluation of the analog signals in Simatic Step 7 space.